Okay, in this question, it's accelerating uniformly. Now that tells us that this is going to be a kinematics problem we can use to solve this. We need to find out the accelerations, so that's an unknown. We don't know what that is. This isn't a projectile motion
figures,
problem.
maybe 1.4
Gaston, by the way, is a dog.
Okay.
And so it's going from rest. So that means his initial velocity is 0. And the time is
what is the size and direction of velocity at the highest point?
And the distance is 2.3 meters.
Okay, so this is similar to the previous question.
What information we have,
so
and
she's going at 5.1 meters per second at the highest
point.
What
we need to find out. So what are we trying to find out? Acceleration and
the size.
Don't need to find final velocity. So can we find an equation
meters per
which
second.
has acceleration and
direction
doesn't
just
necessarily have
to
final
right.
velocity and it doesn't have it in?
Okay, so if we carry on with that.
Okay, so if we look through the equations, we come across this one: initial velocity times time.
Air resistance, so the velocity remains unchanged. That's pretty much the same answer. So that's a question that does come up a little bit.
Equals 0 times time, which I could put time in as 0.81, but it doesn't really matter because this is going to end up being equal to 0, so it doesn't really matter, does it? Plus half times a times t squared, which is 0.81 squared. Okay, so go and do a couple of calculations with that. Okay, so all I've done there is I've rewritten this equation here. I've still got the half in it. The a is what we're trying to find out, and this has just been squared here to get there. Now I can get the half onto the other side, and at the moment it's time, so I could change it to divide. So 2.3 divided by 0.5, that's 4.6, equals 0.6561 times a, and then we carry on, and that's going to be 4.6 divided by 0.6561 equals a. Okay, so if we follow that through, that equals 7 meters per second. So it goes from there. We divide 4.6 by 0.6561. That's going to equal the acceleration, and that equals 7 meters per second. One thing you can do if you're a little unsure of your algebra, like I'm not quite sure about that, because you will have time at the end of the year to do this, is you could put that number back into the equation over here. Obviously this still equals 0, and check that it does equal that distance. That could be done as a double check. Okay, now we've got ball being kicked, and it's in the air for 3.3 seconds, so that means it's going to be half that time to get to the peak, and it hits the ground 47 meters away. Okay, there's supposed to be a question on here, but obviously I've missed it out. So the question is, calculate his initial velocity. I must have left that out. Right, so if we know the distance is 47 meters, and we know he was in the air for 3.3 seconds. We know the horizontal velocity is constant through that time, so we can use a formula: velocity equals distance divided by time. So, and that will give us that. But hopefully intuitively you would kind of know that anyway. So if we do that as a calculation, we get 14.24 meters per second is the horizontal velocity. So that's the horizontal velocity we've got at the moment. Okay. Now if we get rid of this, we're now trying to calculate, because effectively what we're trying to do is, this is really just a bit of Pythagoras. If we want to know that velocity there, we need to know the horizontal and the vertical. We've just done the horizontal, so now we need to know the velocity for the vertical. So the time for that is going to be 3.3 divided in half. So that's 3.3 seconds over 2 equals 1.65 seconds. So that's the time. We know the initial velocity is going to be equal to 0. We know the acceleration is going to be minus 9.8 meters. Sorry, not the initial velocity is going to be 0. Sorry. The initial velocity is the unknown we're trying to figure out. The final velocity is equal to 0. So that's what we're trying to figure out. The initial velocity is the vertical velocity. So we don't have VF, and we don't have distance, which is the height. So if we have this formula, VF equals VI plus AT, we know that that's 0, which equals VI, which is the unknown, minus 9.8 times by T, which is 1.65. So 9.8 times 1.65, and that equals 16 meters per second. Okay, so we've just worked out the vertical velocity is 16 and the horizontal is 14. So at this stage you should know if that's 16 meters per second and that's 14.24 meters per second, then we can use the fact that of Pythagoras that 14.24 squared plus, I don't know why I did it like that, but anyway, I'll carry on doing it like that in my own little weird way. Should put the squared in there. Squared equals the initial velocity with that angle. What was that? And that's obviously going to be that squared. Anyway, you know what I mean. So 16 squared, so that's 261.46 is this one. 14.24 squared is 202.77 plus that. So that equals 464.23. That's your answer. So if you take the square root of that, because it's that number squared, that should give you your velocity. So, and that's 21.54 meters per second, which you can round if you choose. Okay, and I know this has got nothing to do with kinematics or projectile motion. I just thought you'd like to see what Gaston looked like. Now here he is. For some reason they're suspending him there because I think he's overweight apparently. Anyway, so what was his mass again? 72 kgs was it? He really is a big boy. Anyway, where is it? Yeah, 72 kgs. It's a little bit lighter than me. So we've got a weight force coming down here, 72 kgs. Remember to times it by 9.8 because that's what we use for our constant. So that's 705.6 newtons going down that way. Now we could use vectors to solve this, which would be the vector for that one, and then that one, and then we've got that one coming down there to work out what those two are. But we can just use Pythagoras as well. So at that stage, the weight force going down there is going to be split between these two. So it's going to be that divided by 2. Because there's 2 ropes. If there's only one, it would be the whole thing. So that's 352.8. Okay. Now that angle there is 45 degrees. So we're wanting to know what that is on that side there. So what do we use for that? Well, that's a hypotenuse, and this is opposite, so we could use sine for that. So sine 45 degrees equals opposite, which is 352.8 over hypotenuse. Okay, because that's what we want to know there. Force diagram would be this. We haven't done them yet. This would be the weight force going down. This is using vectors, so I'm just interested in calculating the tension force. So sine 45 is going to be 0.7071. So hypotenuse is going to equal 352.8 divided by 0.7071. So 352.8 divided by 0.7071 equals 498.93. And if we round that till we see if that is going to be 500 newtons in each rope. Okay, and that's in each of these support ropes. Okay, and that's that.